Lesson 1.6, Solving Linear Inequalities. A linear inequality in one variable might look something like this. 7x plus 2 is less than 23. A solution is a value which results in a true statement. The graph represents all possible solutions. So let's go ahead and take our 7x plus 2 is less than 23, and we're going to solve it. And we're going to solve it just like we would an equation. Normally, instead of the inequality symbol, we would see an equal sign. So we would do the inverse operation. We subtract 2 from both sides. 7x is less than 21. We divide both sides by 7. X is less than 3. And now we're going to graph it. Okay, so the graph would look something like this. We would circle the 3 and then highlight everything to the left of 3. We use a hollow circle to show the 3 is not a solution, but every single value less than 3 is. So 2.9999 is a solution, but 3 is where it stops. It's not included. So next, let's see when we'd actually fill in the circle on the graph. Okay, so we have negative 5x plus 7 is less than or equal to, we have an equal to bar, 27. So again, we're going to begin with our inverse operation, end up with negative 5x is less than or equal to 20, and now we're going to divide both sides by negative 5. And something happens when we divide by a negative. We're going to reverse the inequality symbol. So we end up with x is greater than or equal to negative 4. And now we're going to graph this one. Okay, so again, remember we reverse the inequality symbol when we divide or multiply both sides by a negative. So we started off with less than or equal to, and it became greater than or equal to because we divided both sides by that negative. Now we're going to go ahead and graph it. So it says x is greater than or equal to negative 4. So in this instance, we want to include the negative 4. So we fill it in, and then we highlight the graph to the right. So all values greater than and including 4 are solutions. So let's pick a number that's greater than negative 4. Let's pick 10. So if we went back up to our original inequality, negative 5 times 10, so we chose 10 for our x value, plus 7 is less than or equal to 27. Negative 50 plus 7 is less than or equal to 27, and that's a true statement. Negative 43 is less than or equal to 27. So any value you pick on the number line that's greater than this negative 4 to infinity is going to be a solution. So a compound inequality is made from two basic inequalities joined by and or. So the one that I have here that we're going to start with is an and statement. It's one big inequality. And when it says it's made from two basic inequalities, we can solve it by breaking it up into two parts. Negative 13 is less than 3x minus 7. And we can write, we're going to reuse 3x minus 7 is less than 17, and we can solve these two inequalities separately. So we used the middle expression twice. But we don't have to break it apart. What we can do is just start with our adding 7 on both sides. So we end up getting negative 6 is less than 3x less than 24, and then we're going to divide all terms by 3. So negative 2 is less than x, and we have less than symbol and our 8. and now we're going to graph it. So the idea was we were working to isolate the x. So in order to graph it, we're going to start reading from the x. X is greater than -2. So there's no equal to bar, so it's going to be a hollow circle, and we start highlighting the values that are greater. Then we're going to go again to the x, and it says x is less than 8. So we start at the 8. It said x was less than, so it's hollow again, and now we start highlighting towards the values that are less than. So when we have an and statement, our graph is going to look kind of like a barbell. That's not a math term, that's just a way to remember it. So again, now if we go back to how we broke up our compound inequality into two smaller ones, if I added 7 to both sides, we'd still end up with -6 is less than 3x, divide both sides by 3, and we end up getting our -2 is less than x. And that's what we had over here. And then on this side, if we add 7 to both sides, 3x is less than 24, divide by 3, we end up getting x is less than 8, and that's what we had there. We have one more example to look at. Okay, on this side we have an or statement. It's just two inequalities. I solved the one on the left, I solved the one on the right, and you can see that here we have an equal to, so it's filled in, x is less than or equal to, so we highlighted everything that's less than, and over here it ended up to be hollow because there's no equal to bar. An or graph is not connected. Sometimes it depends on what your inequality symbol is, but you might end up with two filled in dots or points, or you might end up with two hollow. It just depends on the original inequality.